So to do this, we need to find out what this line is. So we can figure out that A is this bit here. I'll colour it in blue. So this equals A, because they're both the radius. To figure out this little bit here, we're going to need to use Pythagoras' theorem, which it'll equal, we're going to name this dot for the minute. So dot will equal A squared minus R squared. That'll be dot squared, because that's Pythagoras' theorem. But we can figure out that this little bit in green, we can figure out that that will be x minus a. So we can sub that in. And that's squared because it's Pythagoras' theorem. So next, what we are going to do is we're going to make r the subject. So we bring r over here. R squared equals a squared minus, because we're bringing that over to the other side, we need to change what it is, x minus a squared. So the volume of the cone is V equals 1/3 pi r squared h. So if we're going to sub this r into there, what we need to do is go V equals 1/3 pi a squared x minus a squared, that's a minus there, and then h on the end. Now we know that h, the height, is x, so we can just put that in instead of h to make things easier. Whoops. So next thing we're going to do is expand this out. V equals 1/3 pi a squared minus x minus a x minus a x. Okay, so next we're just going to times these together. So V equals 1/3 a squared minus, so we're going to do this. Expand this like that. So with that we will get, this is a negative x squared. And then negative x times negative a will be a positive ax. The negative, which changes this to a positive in the middle there. So then we get positive a and x, which makes another positive ax. And then we have positive a with positive a, which equals positive a squared. And then we just put the x on the end. Next thing we can do is just make that prettier. So we can plus these together. Plus 2ax. So I made a mistake, and that is a negative a. And then what we do is we can just cross those out, because a squared minus a squared is 0. And then what we can do is V equals 1/3 pi, and then we're just going to move this x to the front here. And then we're just going to times that into here, so that will disappear. Make this a 3, and make this a 2. And then we have what we have up here. So just rewrite it up here as V equals 1/3 pi 2ax minus x cubed. And there you have what this is. So for this equation, the first thing we're going to do is to find stationary points. We have to derive by the first derivative. So if we write that here, we are going to take the first number and we are going to times it by the indice and then take one away from the indice. So it'll turn out to be 12x cubed. And then we're going to keep doing that to the other two. And then what we're going to do is we're going to factorise this. So 12x is a main factor in this equation. Like that. And this is a monic quadratic, so we're going to factor that as well. Then there's a negative here, so there'll be a positive and a negative in this equation. And the positive will be 2, the negative will be 1. Then from there, we can gather that our stationary points are 0. So when that turns to 0, this will equal 0. Negative 2 and 1. So the next thing we do is we're going to determine the nature of these stationary points. And to do that, we need to get second derivative. So we're just going to do the exact same thing we did to the first derivative to get a second derivative. So it'll be like that. And then what we're going to do is we're going to sub in each one of these into the equation and determine whether they are maximums or minimums. So this one will equal negative 24. So that means that 0 is a maximum. You can tell whether something is a maximum or a minimum because a negative is concave down. And then so it'll have a maximum here. This is the point you're finding. The very maximum it can go up on the graph. That's the point we're finding when we're saying a maximum. And so if it's a negative, it's a max. If it's a positive, it'll concave like that. And this is the minimum point. So that's how we get those. And now we're just going to put in the rest of these. And so this is minimum because it's a positive. And then the last one. That'll just be really easy. Like that. So now we can write these over here. Now what we're going to do is we're going to get the full coordinates of each one. So we're going to again sub these into the original equation, and that will give us the y values because these are the x values. So that will just, because anything times by 0 is 0, that'll just equal 0. So then for that we will have 0, 0 is a max. So that. So that's for the 0 here. Next we have 2. So now we know what all the coordinates are. We can go in and sketch the graphs showing the stationary points. So we're going to have a maximum at 0, 0, which is here, at 1, negative 5, so about here, 2, negative 32, which is about like all the way down there. We're going to have another one. So if we were to sketch this, it would be something like that. So now what we do, if we want to find the values for the function of x is increasing, what we do is write the first derivative, so if we look over at the graph, the point where it's increasing between the 2 is here, and between the 3 is here. And so we can say x is increasing between negative 2 and negative 32 and 0, 0. Okay, so for number 4, what values of k will this have? We can just look at the graph, and anything above negative 32, we can say that for what value of k it will have no solution because it's above that.